Lesson 7.4, Applying Properties of Similarities. Your objectives are to use properties of similar triangles to find segment lengths and to apply proportionality and triangle angle bisector theorems. Artists use math techniques to make two-dimensional paintings appear three-dimensional. And the invention of perspective was based on the observation that faraway objects look smaller and closer objects look larger. If you don't immediately picture this, you can think of dilations. We take a small object when it's far away and we bring it closer, it gets larger. Mathematical theorems like the triangle proportionality theorem are important in making perspective drawings. Theorem 7.4.1, the triangle proportionality theorem states, if a line parallel to the side of a triangle intersects the other two sides, then it divides those sides proportionally. As you can see in the picture in triangle ABC, EF is parallel to BC. That means that AE over EB is the same proportion as AF over FC. We can use this to find the length of a segment. In this problem, we want to find US. It's given that ST is parallel to UV. That shouldn't be equal, it should be parallel. So US over RU will be proportional to VT over RV by the triangle proportionality theorem. If we substitute 14 for RU and 4 for VT and 10 for RV, we come up with US over 14 equals 4 over 10. Cross product property gives us US times 10 equals 56. If we divide both sides by 10, we get 5 3/5. If we want to verify that segments are parallel, we need to prove that the sides are proportional. So we want to verify that DE is parallel to BC. AD over DB equals 10 over 15, which is 2/3. It's a loud airplane. AE over EC equals 8 over 12, which is also 2/3. Since AD over DB equals AE over EC, then DE is parallel to BC by the converse of the triangle proportionality theorem. We have a corollary, the two transversal proportionality. If 3 or more parallel lines intersect two transversals, then they divide the transversals proportionally. So if AB, CD, and EF are all parallel lines, then AC over CE is going to equal BD over DF. An application for an artist using perspective. Suppose an artist decided to make a larger sketch of the trees. In the figure, if AB is 4.5 inches, BC is 2.6 inches, CD is 4.1 inches, and KL is 4.9 inches, find LM and MN to the nearest tenth of an inch. So if we look at our picture, we are given that AK, BL, CM, and DN are parallel lines. The two transversal proportionality corollary says that KL over LM is equal to AB over BC. Substituting in 4.9 for KL, 4.5 for AB, and 2.6 for BC, we get a proportion that we can solve. We use the cross products property and divide both sides by 4.5. LM is about 2.8 inches. To find MN, we also use the two transversal proportionality corollary. KL over MN is equal to AB over CD. If we substitute in the values that we were given, we come up with 4.9 over MN equals 4.5 over 4.1. Using the cross products property, we have 4.5 MN equals 4.9 times 4.1. And if we divide both sides by 4.5, we get that MN is approximately 4.5 inches. The previous theorems and corollary lead to the following conclusion. And this is the triangle angle bisector theorem. An angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So your picture would show two congruent angles. So we would know this would be that AD is the bisector. And if it is, then BD over DC is the same as AB over AC. Let's use that and find PS and SR. PS over SR equals QP over QR by the triangle angle bisector theorem. If we substitute the given values, we have x minus 2 over x plus 5 equals 32 over 40. Using the cross products property, we have that 40 times x minus 2 equals 32 times x plus 5. We distribute and we get 40x minus 80 equals 32x plus 160. Continuing our example, we simplify and we get that 8x equals 240. Dividing both sides by 8, we come up with x equals 30. Substitute 30 for x in both of the sides, and we have PS equals x minus 2, which would be 28, and SR equals x plus 5, which would be 30 plus 5, which is 35. Now you try.